All right, we'll have a quick look at this question. So this is a typical GMAT 700 plus data sufficiency question. So the question is stating that x cube is greater than x square. And they have given two statements, x is greater than 0 and x is less than 1. So first, with respect to the data sufficiency question, we are going to understand that what are the situations when we are going to accept the statements and when we are going to reject it. So with respect to acceptance, when we are going to have x cube is greater than x square, yes, we want to accept it, right? That is what the question is really seeking out. Now, when we are talking with respect to x cube is less than x square, nope, we are not going to accept it. Okay, it's a rejection. One more situation, what many students that I have seen, they avoid it, is when x cube is equal to x square. This is when they do not really take this particular criteria into consideration. That's also a rejection, right? So when it is less than and when it is equal to, it is a no. We have to reject it, correct? Now, super quickly, let's go back to the question again. X cube is greater than x square. Now, anywhere in this question, is it stated that x is an integer? No, it's not. So x can take any value, right? It can take 1, it can take 0.8, 0.2, 0.005, anything. So basically, x is a real number, correct? X is a real number in this situation, right? It is not pertaining specifically to integers, correct? Let's now delve into the question straight up. We'll take the first statement. Statement 1. Now, statement 1 is stating x is greater than 0. That means that x is going to be a positive number for sure, right? Now, my objective is to plug in the values, right? Different values we are going to see, and we want to prove insufficiency, right? So we want to plug in values to prove insufficiency, right? Basically, we want to understand different values of x and we want to make sure whether the continuity uniformity is there or not, right? You need to have a uniform answer. It can be in the form of like, yes, 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 or it can be in the form of no, 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 right? Whatever it is, it has to be uniform answer. I can't have like different type of answers, right? Then I would want to reject it, correct? So let's start. I am taking up, let's say, a very convenient answer. X is equal to 2, right? Now x is equal to 2. I am taking x cube is going to be 8 for me and x square is going to be 4. So I am having x cube is greater than x square. It's a yes. The statement is correct. Now I don't want to commit a mistake of just taking one value. Okay, so I'm going to be taking another value. Let's take 1. Here I'm having x cube is 1 and x square as 1. So, well, as what I have seen over here, that it cannot be even equal to because my inequality is straight up saying greater than, right? So I'm going to have a x cube is equal to x square, so a no, right? I can take one more value, right? I can take one more value to just understand. Let's take it's between less than it's between 0 and 1. So I can have, let's take x is equal to 0.5, right? Here also I'm having x cube is less than x square. So it's a no. So as what I am being able to see that it's inconsistent, right? It's yes, no, no. So definitely statement 1 is not sufficient to answer the question, right? So definitely option A and D I am going to eliminate, right? I'm left with the other options, B, C, and D, right? So let's quickly check for second statement. Statement 2. What is our statement 2? X is less than 1, right? X is less than 1. Now, many students, they again commit a mistake. They feel that X is less than 1. That means we are only talking about 0 to 1. Nowhere it is stated. It can take any values, right? It can be from minus infinity to 1, correct? 1. So here also I can have different criteria, right? I can break it down to minus infinity to minus 1, correct? I can check with respect to x is equal to 1, minus 1, sorry. And I can take from minus 1 to 0, correct? One situation I can take it. Any one value I'll plug in. X is equal to 0, and I'll take 0 to 1, right? Let's go. Minus infinity to minus 1. So minus infinity to minus 1, what am I having? I can take any number. I can take x is equal to 2, minus 2. So x cube is minus 8 and x square is minus 2, 4, right? So I have minus 8 is less than 4, correct? That means it's a no, right? X cube is less than x square. It's a no, right? Let's move on to next statement. Sorry, x is equal to minus 1. So x is equal to minus 1, what am I going to get? X cube is minus 1 and x square is 1, right? So minus 1 is of course less than 1. So again, I'm having a no, x cube is less than x square, right? X cube is less than x square, so it's a definite no. Next, minus 1 to 0, any value, typical half, minus half, right? So I can take minus half. So what am I getting? X cube is minus 1 by 8 and x square is 1 by 4. So I'm having minus 1 by 8 is less than 1 by 4. Again, it's a no, right? It's x cube is less than x square. X is equal to 0. Well, both will be 0, right? 0 is equal to 0. So it is x cube is equal to x square. If you remember, this also is going towards 0. That's a no. 0 to 1, any value again, a typical value we'll be taking midpoint, that's half. That is going to be 1 by 8 is less than 1 by 4, correct? So again, it comes to no. Now, if we notice here, aren't we having a uniformity? No, 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 correct? So I can definitely say that option B, that is statement 2, is sufficient to answer the question. There you go, guys. Option B is our answer. That's it.